In this question, we are going to find a value for the bond enthalpy of CC bond in cyclopropane. We are given the skeletal formula of cyclopropane. It shows us that cyclopropane has 3 carbon atoms. Each carbon is bonded to 2 hydrogen atoms. So it's a total of 6 hydrogen atoms. Molecular formula of cyclopropane is C3H6. We are given a few enthalpy changes values here. The first one will be enthalpy change of formation of cyclopropane. So let's write an equation for the formation of cyclopropane. Enthalpy change of formation is for 1 mole of the compound from its elements. We have carbon, we have hydrogen here. So its elements will be carbon, standard state, solid. I need 3 carbon. Hydrogen, the element will be H2 gas. 6 hydrogen atoms here, that means I need 3 H2 molecules. The enthalpy change value for this reaction will be positive 53.3. And the second information, we are given the enthalpy change of atomization of graphite. Enthalpy change of atomization is for breaking of all bonds and form 1 mole of gaseous atoms. So we want to get 1 mole of gaseous carbon because graphite is actually a type of carbon. So breaking all the bonds in this solid carbon, we are going to get 3 moles of gaseous carbon atoms. Now the enthalpy change of atomization of graphite given here is positive 717 kJ per mole. It's for 1 mole of graphite. Here I have 3 moles, so the enthalpy change for this reaction will be 3 multiplied by positive 717. So the third information given to us will be the bond enthalpy of HH bond. Bond enthalpy means breaking of a covalent bond. So this is for breaking of the covalent bond between the 2 hydrogen atoms. Breaking the bond between the 2 hydrogen atoms will give us 2 gaseous hydrogen atoms. Here we have 3 moles of hydrogen molecules. Breaking of all the bonds between the HH in all 3 hydrogen molecules, we are going to get 6 hydrogen atoms. So the energy change for this reaction will be 3 times 436. Why multiply by 3? Because this bond enthalpy is to break 1 mole of the bond. Now we have 3 moles, so multiply by 3. Now to form a complete cycle, I need to put 1 more arrow from the cyclopropane to gaseous carbon atoms and gaseous hydrogen atoms. So that means I'm breaking all the bonds in cyclopropane for this reaction. There are 3 CC bond, 1, 2, 3. There are also CH bonds, 1, 2, 3, 4, 5, and 6. So the sum of all these bond energies will be the energy change in this reaction. We have a Hess cycle now. We can use Hess's law to find the bond energy of CC bond. For this reaction on top of the cycle, from the left to the right, will be the direct one-step reaction. The indirect pathway will be from graphite and hydrogen going down first, then go up again. So for this indirect pathway, the 2 arrows on the left, there will be no change, but the arrow on the right-hand side, I have to change the direction. So I'll do that in my calculation later by placing a negative sign in front of these enthalpy change values. So now I know the relationship between all these enthalpy changes. Let us put them in the equation. So in the equation, you can see that I place negative sign in front of these two bond energies because I want to change the direction of the arrow. Right, we have the bond energies of CH bond. That's the fourth information that is given to us here. So I'm going to substitute the bond energy of CH bond to 410. Now we'll be able to find the average bond enthalpy of the CC bond by rearranging this equation. The average bond enthalpy of CC bond is 315 kJ per mole. So the answer to this question is B.